All right, hello everyone. My name is Eric Roos, and this is a continuation of our basic map reading series. And this presentation, this video, will be on contour lines. Contour lines, they're critical for understanding terrain, the ground, and along with the terrain features, putting the two together, you can truly understand your operating environment and what's going on the ground and where are the best places to go. For example, using contour lines, which are just lines on a map, you'll see in just a moment, where are the mountains? Where are the valleys? Where are the spurs? Where are the ridge lines? Where is the highest point? The highest point is critical in case you need to get high up in the air for observation purposes or to place an antenna to ensure your communications. What is the best route to get from point A to point B? Do you really want to fight to claw your way up a steep mountain just to get to the other side of the mountain where you got to fight to keep from slipping once you get over the top? Or is there an easier way to get to the other side of the mountain? All that is determined by contour lines. Where are cliffs and depressions that would impede my movement? You don't want to pick a route to go someplace only to see yourself faced with a cliff, and you may have to go back and then around and all this other stuff. You've just wasted time and energy. So understanding contour lines from this video, terrain features in another video, you'll truly be able to master terrain so that you can use the best use of it, maximize it, and save time and energy, especially if you're on foot. So here, this is what we're talking about. These are the contour lines. It looks like a mess, very dizzying mess. But by the end of this little presentation, you are going to make complete sense out of this mess here. You'll know what they all mean. Okay? Have no fear. Just hang on. This is basically the same thing, only at a much smaller scale. Here's a piece of terrain, piece of ground, and we have a line here that says 5, 10, 15, 20, and 25. What do they mean? Well, down here, this measure here, this distance scale is in feet. So we can assume that these are also measurements in feet. And what they mean is the distance above sea level. So every point on this line here, this bottom line, is 5 feet above sea level. Then every point on this line here, 10, is 10 feet above sea level, and it goes all the way around. 15 feet. So here, the easiest one to see, because these lines are so close, is here, 25. Every point on this line is 25 feet. So as you can see, you go from 5, you increase to 10, increase to 15, increase to 20, increase to 25. You are going uphill this entire way. Now, you cannot assume that this is a completely flat surface. This is not a pancake on top of the mountain, because all these are increasing in elevation. So you can assume that from this 25-foot mark, it also increases. But you know it doesn't increase by a full 25 feet, a full 5 feet. So you know the top here isn't 30 feet. So the rule is to take half of the distance between these marks here and add it up here. So all these lines are 5 feet in elevation apart. So half of 5 is 2.5. So you add 2.5 to 25 and you get 27.5. So what one can assume as a good operating rule that this top here is 27.5 feet above sea level, and then you go downhill from there. Another thing, notice that you have to walk this far on this map. Basically, it looks like maybe 550 feet. You're walking for 550 feet, let's say, to go from 5 feet above sea level up to 25 feet. As compared to right this way, you only have to walk about 100 feet to go from 5 feet to 25 feet. So this way here is much steeper than this way. So if you don't mind taking the time to walk that many feet, and maybe you're carrying a lot of weight or the way is slippery, this may be the way to go. But if you're strong and light and the terrain is favorable and you got to get there in a hurry, you can probably scramble up this side of the mountain and get up to the top sooner than maybe this. There's all kinds of variables at play. All I'm saying is this is a gradual route but longer. This is a shorter route but harder. Okay? Oh, and notice here's the north. There's like a compass point. This way shows that it's north. Okay? So obviously west is to the left, east is this way, and south is down. So again, I kind of stole the thunder on this slide, but again, look how far these lines are apart. So this is, just use this as a baseline. You can see that since these lines are tighter than over here, this is a gradual slope compared to this steep slope, and this is a steep slope compared to that one. Now this one is this distance is in meters. The other one was in feet. This one is in meters. The other one had a distance of 5 feet between elevation lines. This one has 20 feet. So we go from 280 down to 260, down to 240, down to 220. This one's not marked. That'll give you one guess what it is. 200 meters. Also, what would be the elevation that we can assume is the top of here? If the last contour line is 280, what will be the height of this mountain? Well, the distance is 20. Half of 20 is 10. So we add 10 to 280, and we get 290. So we can see we go from 200 meters up to approximately 290 meters by going from the bottom of the hill up to the top of the hill. This is a gradual slope. This is gradual. This is a little less gradual, and this is much less gradual. Okay, and again, every point on the contour line is that elevation. Okay? So here we go. Here's that same thing again. I think by now you know. This is a steep slope, gradual, very steep. Now here is the Mauna Loa volcano on the island of Hawaii. So here we have miles here. This is in feet. So we can assume that these thousands markings are all in feet. So we can see that the last contour line here is 13,000 feet, and all the lines are 1,000 feet apart. So what can we assume is the height of the very top of this mountain? 13,000 plus half of 1,000 is 13,000 plus 500, or 13,500. Now notice, you don't see any contour, there's no numbering of contour lines over here. Well, we know that the lines are all 1,000 feet apart. So you just find one line that is marked, and you come over here. So if you need to find out how tall that place is, you just count them. 4,000, because that's marked. 5,000, 6,000, 6,000, 7,000, 8,000, 9,000, 10,000, 11,000, 12,000, assuming I didn't lose count. Let me do that again. 4, 5, 6, 7, 8, 9, 10, 11, 12, 13,000 again to the top of the mountain, but to the last contour line. So again, you can assume that the very top is half again of what the contour interval is. So again, 13,000 plus half of 1,000 is 500. 13,500. So one can assume that these two peaks are basically the same elevation. Down here, however, this is 3,000. So the next one's not marked, but we know it should be, well, we know it is 4,000. And the very top of that little knoll, I guess you can call it, 4,000 plus 500 is 4,500 feet. Here again, this one here. So we see a 5,000, 6,000, 7,000, 8,000, and again 8,000 plus a half. We have 8,500 feet for that little tiny top of the mountain there. So there's that. So here we are on our Elk Lake map. We can just talk about that a little bit. I hope you can see it. So here we have basically a flat area. There's really no contour lines in it except for one line, two line. So here it's a flat area. They have with like four or five different little hills on it in this little flat area. But then move just a little bit further and you got all kinds of contour lines. So 5,000, and here this is what I wanted to point out in this one. In this one, there's only certain lines that are marked with numbers, and they have a different color and they're thicker. Those are called index contour lines. An index contour line, they are the ones that have numbers on them, and the ones in between are just regular contour lines and they're not marked, and they're generally every 5 lines. So you have 5,000, and then you have unmarked 1, unmarked 2, unmarked 3, unmarked 4, and then the 5th one is the next contour line. So this is 5,000 feet, I presume, and this is 5,200 feet. So you can do the math to find out what each contour line is in between. And I hope you don't hear that basketball bouncing around. But, and again, over here, look, over here at Elk Mountain, we have very gradual slopes here, gradual. But look at this way here. This side of Elk Mountain is basically a sheer cliff. So if you wanted to get to the top of the mountain, well, if you wanted to go up this way, you'd probably need special gear, lots of ropes, risk having people fall backwards and drop things and have things fall down the hill, as compared to maybe, this is safer, it's longer, but you won't wear yourself out maybe. You shouldn't have any injuries compared to maybe what you would expect here. So again, if you do your analysis, what is the best way to get to the top of Elk Mountain? Alright, so there's other things on here we'll talk about in other videos. But for right now, I think now you should have the gist of what a contour line is and how you can use it to determine elevation and how you can use it to figure out how the terrain is structured.